So today we're going to look at some basic factoring of some binomials. And as you can see from this example right here, that we have 4x minus 2z, and what they've done is they've factored out a 2 from both of those factors, or from both of those terms. So in other words, if you were to go ahead and write in here, or multiply 2 times 2x, you get back to the 4x, and multiply 2 times negative z, you get back to the 2z. Again, this is just another way of writing your expression, but in a factor form. So let's take a look at another one of these, 6a minus 3b. So let's go ahead and factor out a 3 from here. So now the question is, what times 3 gets you 6a? Well, that's going to be 2a. And what times 3 gets you negative 3b? It's going to be negative b. Next one, you can see that they have a y in common here and here, so I'm going to factor out that y. And then 5 times y is 5y. And then z times y is yz. That's your basic factorization of these simple binomials. Next, let's take a look at these simple factoring by grouping problems. We can see that x plus 5 and the other x plus 5 are common factors of this whole expression. So we're going to write that one factor down. And again, order doesn't matter where you put it. If you put it first or second, it doesn't matter. The only other factors left is 3 and negative y. So guess what? That's the other part of grouping these, or factoring by grouping. So we've written this as a multiplication problem instead of a series of addition and subtraction problems. Same thing here. We've got n minus 2 as a common factor, so we're going to write n minus 2. And then m minus 2 as your other factor. Now let's take a look at factoring by grouping, and you'll see that there's a connection between how to factor these type of problems with the ones we just did. Since these two have something in common, we're going to group them, and then we're going to group the other ones. Remember to put your brackets in between the operation and this variable. Now take a look at what you can factor out. Both of these have an a squared in common, so I'm going to factor out an a squared. What times a squared is a cubed? Well, that's going to be a. What times a squared gets you a squared? It's simply going to be 1. And there's always something that you can factor out from these if they don't have something in common, and that thing is called a 1. It may not seem like much, but believe it or not, it creates a factorized situation. Again, we just got back to the problems we were working with. We have a common factor of a plus 1. And our remaining factors of a squared plus 1. Next one here, these two have something in common, so we're going to go ahead and factor or group them, please. And then put your brackets in between the operation and this term. Now, we originally had negative 3x and positive 6. But since we put this bracket in here, we have to change this sign, and here's why. If we distribute this negative to the positive 3x, we get back to negative 3x. And if we distribute this negative, we have to change this to a negative right here, so that when you multiply a negative to a negative, you get back to the original plus 6. Now that we have what we call happy cows in all these corrals, let's factor out what we can. An x is in common here, and a 3 is in common here. And again, we got back to the previous problems we were just working on. So we're going to have x minus 2 as one of our factors, and then x minus 3.